M1 Abrams main battle tank, 1980s. Engineering power for a real world. The 1980s were defined by anticipation rather than peace. It was a decade shaped not by open conflict between superpowers, but by the certainty that if war came, it would arrive without warning and without restraint. The Cold War had matured into a standoff where both sides understood the consequences of hesitation. Europe was widely expected to become the primary battlefield. Vast armored formations stood ready on both sides of political borders. Military planners no longer asked if armored combat would occur, but how fast it would escalate and how survivable their forces would be once it did. In this environment, older armored vehicles were increasingly viewed as liabilities. They reflected design assumptions rooted in earlier conflicts, assumptions that no longer aligned with the realities of modern weapons, surveillance, and engagement speed. Anti-tank systems had become more precise, engagement distances had increased, reaction times had shrunk to seconds. The United States recognized a critical truth. A tank that fails in the first moments of contact is worse than useless. It endangers its crew. The response was not incremental improvement. It was a complete rethinking of what a main battle tank needed to be. That response became the M1 Abrams main battle tank. Strategic context: why the Abrams was necessary. To understand the Abrams, it is necessary to understand the world it was designed for. NATO planners in the late 1970s expected any large-scale conflict to involve rapid armored advances, contested airspace, electronic warfare, and overwhelming firepower. Tanks would no longer fight in isolation. They would operate as part of integrated systems involving infantry, aircraft, and artillery. Survivability was no longer defined solely by armor thickness. It was defined by detection speed, engagement accuracy, crew protection after penetration, reliability under constant stress. A tank that could not keep pace with this environment would not merely be outdated, it would be lethal to its operators. The Abrams was designed as a response to this strategic reality. It was not created to win individual duels. It was created to function within a high-tempo, system-driven battlefield. Design philosophy: engineering for failure scenarios. Unlike many earlier tanks, the Abrams was designed with failure in mind. Engineers assumed the tank would be hit. They assumed systems would be stressed beyond ideal conditions. They assumed crews would operate under extreme fatigue, noise, and psychological pressure. Rather than attempting to prevent every failure, the Abrams was designed to absorb failure without catastrophic loss. This philosophy shaped every aspect of the vehicle. Armor systems: intelligence over thickness. By the 1980s, traditional steel armor had reached its practical limits. Simply adding more steel increased weight without proportionally increasing protection. Modern anti-tank munitions were designed specifically to defeat homogeneous armor. The Abrams introduced advanced composite armor systems, using layered materials engineered to disrupt incoming projectiles rather than simply resist them. These layers worked together to reduce penetration effectiveness and dissipate energy. Angling and spacing were critical. The armor was not uniform because threats were not uniform. This approach dramatically increased crew survivability. Even when the armor was struck, the likelihood of catastrophic penetration was significantly reduced. Crew protection: designing for the human factor. One of the most important aspects of the Abrams was its internal safety design. Earlier tanks often treated the crew as secondary to the machine. Ammunition storage was integrated into crew compartments. Internal fires frequently resulted in total loss. The Abrams changed this approach. Ammunition was stored in separate compartments equipped with blow-off panels. If ammunition detonated, the explosion would be directed away from the crew rather than through them. Fire suppression systems were integrated to react automatically in emergency conditions. These features acknowledged a fundamental reality of combat. Crews survive wars. machines can be replaced. The engine, responsiveness over efficiency. The Abrams gas turbine engine was a controversial decision at the time. Diesel engines were more fuel efficient and familiar. Turbines consumed more fuel and required specialized logistics. Yet the turbine offered critical advantages: rapid acceleration, smooth power delivery, reliable performance in extreme temperatures. On a battlefield, responsiveness matters more than efficiency. A tank that hesitates while repositioning becomes vulnerable. The Abrams did not hesitate. The decision reflected the tank's broader philosophy. Logistical challenges can be solved, but lost crews cannot be recovered. Fire control and targeting, reducing human error. One of the Abrams' most transformative features was its fire control system. Earlier tanks relied heavily on crew estimation. Experience mattered, but experience could fail under stress. The Abrams introduced systems that calculated range, target movement, and environmental conditions automatically. This allowed accurate engagement while the tank itself was moving, an enormous tactical advantage. It meant the Abrams could strike first, strike accurately, and strike decisively. In modern armored combat, the first accurate shot often determines the outcome. The Abrams was built around that principle. 4 operators, 1 machine. Inside the Abrams, the commander, gunner, loader, and driver function as a unified system. Controls are logically arranged, communication pathways are clear, visibility is optimized. The design minimizes unnecessary complexity while maximizing situational awareness. This human-machine integration is one of the Abrams' least visible but most important strengths. Under stress, clarity matters more than sophistication. Performance under fire. When the Abrams entered combat environments, it encountered conditions far beyond controlled testing. Desert heat stressed systems continuously. Fine dust infiltrated mechanical spaces. Enemy forces targeted Abrams units aggressively. The results were consistent: high crew survivability, reliable system performance, psychological dominance on the battlefield. Enemy tactics changed in response. Engagements ended faster. Defensive positions collapsed sooner. The Abrams did not simply fight within the battlefield environment, it reshaped it. Despite its strengths, the Abrams was not immune to time. Years of service left wear that could not be ignored. Electronics aged rapidly as technology advanced. Maintenance demands increased. New threats required new countermeasures. Eventually, operational priorities shifted. Tanks were rotated out of frontline service. Engines were shut down. Vehicles were placed into storage. This was not failure. It was the natural outcome of technological evolution. Storage versus abandonment. Stored Abrams tanks were not discarded relics. They were strategic assets held in reserve. But time still left its mark. Paint faded, seals dried, corrosion appeared slowly. Silence replaced motion. But silence does not mean irrelevance. Understanding before replacement. Restoring a tank like the Abrams requires patience and respect. Before components are replaced, they are studied. Wear patterns reveal how the tank was used. Stress marks indicate operational history. Restoration teams seek to understand the machine before altering it. Modern materials improve reliability. Updated diagnostics improve clarity. Electronics are refined rather than reinvented. The goal is not to erase history. The goal is to preserve function. Return to readiness. When restored systems come online, the Abrams does not feel outdated. Hydraulics respond smoothly. Turret rotation is precise. Fire control systems react instantly. The machine does not announce itself. It confirms readiness.
What the Abrams represents. The M1 Abrams is more than a tank. It represents an engineering philosophy rooted in reality. Expect failure. Protect people. Remove uncertainty. Its success lies not in myth, but in measurable performance. Engineering that endures. Steel ages. Technology evolves. Doctrine changes. But machines designed with clarity of purpose endure. The M1 Abrams main battle tank of the 1980s remains one of the most influential armored vehicles ever created, not because it was perfect, but because it was honest about the world it would face. From preparation to combat, from silence to restoration,